Next is an encoder. So encoder is also a combination circuit, just like in the case of adders or multiplexers or demultiplexers. Encoder is also a combination circuit. That is, you give an input, set of inputs, and you'll get the outputs related to the inputs you have given. Okay, so what is an encoder and where do we use an encoder? We use the encoder in communication systems. So in order for secure transmission of data, instead of sending the data as such, you can code it and send it through a channel. Okay, and you have the transmitter and you have the receiver. From the transmitter you have an encoder. The actual data is coded in some other form and it is transmitted through the channel, and it is received by the receiver, and here you have a decoder which will decode the data from the coded message that it will receive. Here you have the data. This data is given to the encoder. Encoder will code the data and the coded data will travel through the channel to the receiver. At the receiver you have a decoder. Decoder will decode the coded message and will give you the actual data. So this is a normal, very simple communication system. So for this you should know what an encoder, a digital encoder, a digital decoder is. So in an encoder you have less than or equal to 2 raised to n inputs and n outputs. Okay, if there are n outputs, you'll have less than or equal to 2 raised to n inputs. In the case of multiplexer or demultiplexer, the ratio was n is to 2 raised to n. Between the in the case of multiplexer, input and the select lines, and demultiplexer between the select lines and the output. It is n 2 raised to n. Okay, n select lines means 2 raised to n input lines in mux, and n select lines mean 2 raised to n output lines in the case of demux. In the case of encoder, it is not 2 raised to n. It can be 2 raised to n, but it can also be less than 2 raised to n. It needn't be equal to 2 raised to n always. Okay, it is either less than or equal to 2 raised to n inputs. Okay, so encoder, you can name it. There are many names depending on what is the application of what is the kind of encoding that is happening. So encoder, it is normally said as 2 raised to that is okay, we'll just take an example. You can say it as, if it is n 2 raised to n, then you can say that 2 raised to n line to n line encoder. That is one way of calling it. That is, you can say 8 line to 3 line encoder. That is one way of saying it. But it needn't always be 3 and 8. Okay, depends on the circuit. So suppose we'll take the same question, that is 8 line to 3 line encoder. So you have 8 input lines. So we'll just write the truth table. So it is, say, I1, I2, or we will take it as I0. I'll take I8, sorry, I7, I7, I6. I'm just writing it the other way around. I5, I4, I3, I2, I1 and I0. And the output lines are 3. So let the output lines be, say, Y3, Y2 or Y2, Y1 and Y0. Okay, you can name it any way you like. It doesn't make any difference. Okay, so in the case of encoder, only a normal encoder, there are different types of encoders. In a normal encoder, you can have only one input high at a time. Okay, only one input will be high at a time. So if I0 is 1, rest will be 0. I1 is 1, rest will be 0. Like that. So if I0 is 1, all the others are 0. So I0 1 means here you have 0, 0, 0. That is my output. Then next case is I1 is 1. So my output is 1. I2 is 1. Output is 2. I3 is 1. Output is 3. I4 is 1. Output is 4. I5. 5. 6. 7. So this is my truth table. I have 8 input lines and 3 output lines. Only one input line is 1 at a time. All the rest are zeros. Depending on which input line is 1, I'll get the output. So output is 0, 1, 2, 3, 4, 5, 6, 7. So output is 0 when my input I0 is 1. Output is 1 when my input I1 is 1. Output is 2 when I2 is 1. 3 when I3 is 1, likewise. Okay. So this is the actual way of writing the encoder truth table. So you need the output equations. Okay. So output equations, in order to write the output equations, let's see, when is y2 equal to 1? Okay. So y2 is equal to 1 when I4 is 1 or when I5 is 1 or when I6 is 1 or when I7 is 1. In either of these cases, my y2 is 1. Okay. So I can say that my y2 is 1 when I4 plus I5 plus I6 plus I7. And y1 is 1 when 2, I2, I3, I6 and I7. Y0 is 1 when I1 is 1, I3, I5 and I7, or I7 is 1. Yes. So this table, there is another way of writing, a simple way. That is, since in the encoder the input is one, only one input is one at a time. So you can just write it as, instead of writing the entire table, that is if you don't have time, if you have wasted a lot of time, if the paper is very lengthy, then you can write it just like this: input I0. This means that I0 is 1. All the others are 0. I1, I2, I3, I4. You can just write it like this in this particular case only. I6, I7. So this essentially means that input is only this. I0, only I0 is 1. Only I1 is 1. Only I2 is 1. Likewise, only I7 is 1. So you can draw this. You have I1. You don't have a I0 here, so I'm not drawing that. No, you can just keep it like that, but there is no need because it is not there in the equations. So I1, I2 is there, I3 is there, I4, I5, I6, I7, I4, I5, I6 and I7. Yes. So Y2 is 1 when I4, I5, I6, I7, either of them are equal to 1. I4, I5, I6, I7. If any of these are equal to 1, my Y2 is 1. Y1 is 1 when I2, I3, I6, I7. Any of these are 1, then my Y1 is 1. Y0 when I1, I3, I5, I7. If any of these are equal to 1, my Y0 is 1. Okay. So I'll give the inputs here and I'll check what my output Y2, Y1, Y0 is. Okay. So if I keep I0 as 0, all will be 0. I1 as 1, I1 is 1 means Y0 is 1. I2 is 1 means Y1 is 1. Okay, in that there is no other connection. I3 is 1 means you have two connections. So Y1 and Y0 both will be 1. I4 is 1 means only Y2 will be 1. I5 1, Y2 and Y0 will be 1. I6, Y2, Y1, Y0 will be 0. I7, all the 3 will be 1. So that is a encoder circuit.